Back, honors geometry students. I know you've been looking forward to this day for a long time, so I just want to say welcome back. Alright, so chapter 10, okay, a lot of it's going to be on the video here, and we're going to go through some problems, and chapter 10 is all about circles, okay? So before we go through the problems, what you should do, so you understand them, is read through this vocab sheet that is on the front page of your notes, okay? It's got a lot of vocab, a lot of theorems, a lot of formulas that we're going to be referring back to throughout this session, okay? So you should read through this so you're not lost when I'm going through some things and I'm going through problems that involve terms, okay? So make sure before you go through this video that you have read all these definitions and all these theorems. Okay, so let's go to the first problem here. The first example says chord AB. So again, if you go back to our notes here, a chord is a segment that connects any two points on the circle. Okay, so not the diameter, not the radius, but a chord is just a segment that connects any 2 points that are on the circle. Okay, not inside the circle, but on the circle. So problem 1. Okay, I have my circle here. I'm going to do my best to draw circles. It looks more like an egg, but cut me some slack. Alright, so I have chord AB. So somewhere on this circle is a chord. Okay, so we'll say chord AB. And that chord measures 14 millimeters across. Okay, so this chord measures 14 millimeters. And the radius of, that should say circle P, okay, and the radius of circle P is 12. Alright, so here's the center of our circle, circle P, and the radius, okay, so remember what the radius is from the center of the circle to the sides. The radius of circle P is 12. Okay, find the distance from chord AB to P. Okay, so again, like you should have done, like you should have looked through some of the theorems, for this problem, we're gonna use this theorem right here. Okay, it says if a radius is perpendicular to a chord, then it bisects the chord. Okay, the reason we're going to use that is if I were to take, I have this radius PA and PB, but if I were to take another radius, okay, and I were to draw the radius that's perpendicular to this chord, okay, that means that it also bisects the chord. And if it bisects the chord, then that means that this distance would be 7 and this distance would be 7. Alright? Now the problem says find the distance from AB, so from chord AB to point P. So it wants me to find this distance right here, so we're going to call that x. So if I want to go ahead and solve for the distance right here from P to AB, I can go ahead and use the Pythagorean theorem and just say 7 squared, because that's this distance, plus x squared is equal to 12 squared, and go ahead and solve for x. So that would give me 49 plus x squared equals 144. And if we go ahead and solve for x, so subtract 49 and take the square root, we should get x is equal to 9.747 about. Okay? Alright, questions on that one? Nope. Alright, good. Alright, let's go on to the next one, number 2 here. So it's kind of the same idea, except we're going to start with a circle. Alright. Alright, it's the best circle I got right now. Find the length of a chord that is 25 centimeters from the center. Okay, so now we have a circle. It gives us the center here, and it tells us the length of the chord. Okay, so kind of like up here where I had chord AB, I'm going to draw that same chord. Remember, a chord is just the distance between any 2 points on the circle. You really could draw this chord anywhere if you like. I'm just going to go ahead and draw it there. So there's my chord, and it says that the chord is 25 centimeters from the center. So now it tells me that this distance, okay, I'm going to draw, again, like I did up there, I'm going to draw the radius that is perpendicular to the chord. Okay. and it tells me that this distance from P to the chord is 25 centimeters. And then it says find the length of a chord that is 25 centimeters from the center, which I just drew, with a radius of 40. Okay. So now it says that the radius of this circle is 40. Okay? And it wants me to find the length of this entire chord. Alright, well, if we remember from the problem above, anytime that a radius is perpendicular to a chord, it bisects the chord. So this chord AB here, is actually being bisected. Now, we don't know what this bottom part is, so I'm going to call that x, and we can go ahead now and do the Pythagorean theorem like we did up there. So I'm going to say x squared plus 25 squared is equal to 40 squared. And now we can go ahead and solve for x. So if I were to go ahead and solve for x here by doing the Pythagorean theorem, I know you guys have had a lot of experience doing this, so why don't you take a second and go ahead and solve. Alright, so if you solved, you should have gotten, since no one's volunteering right now, you should have gotten x is equal to 31.22. Okay, now, Chembe, what do you think? Is that my answer? No? Why not? Oh, you're right, Chembe. I gotta double that. You're right, very good. Because x is the distance from here to the center, but it wants me to find the entire chord. So I have to go ahead and double that. 31.22 times 2 to get the entire chord. So my answer should be 62.44. Alright. Nice job. Nice job. Alright, let's go on to number 3 here. Okay? So number 3, it says find the distance from the center of the circle to a chord 20 meters long. Okay, so let's go ahead and kind of set up the circle like we've been doing. Alright, so there's my circle. Here's my center. It says the diameter of the circle, so let's go ahead and draw the diameter. It says at the end the diameter of the circle is 38 meters. And it wants me to find the distance from the center to a chord. This is my chord. It wants me to find the distance from the center to that chord, okay, which we'll call x. Alright. If the diameter is 38. Alright, so if the diameter is 38, somebody raise your hand and tell me what this distance right here is going to be. Well, if the diameter is 38, what are my radii going to be? Alright. Yes, good job. They're going to be 19. Right? If the diameter is 38, we know that the radius is half of the diameter, so my radius is going to be 19. Okay? And kind of like we've been doing up here, right, in the previous two problems, okay, here's the distance from the center to the chord. I don't know that, so I'm going to call that x. And it wants me to find that if the diameter is 38. Okay, now there's one piece of there's one piece that it gives me that I haven't talked about yet. It says that the chord is 20 meters long. Okay, so I know that this entire chord is 20 meters. Alright, and if the entire chord is 20 meters, that means that, remember, the radius that's perpendicular to the chord ends up, now I know I didn't draw the whole radius, but you could kind of pretend that if this radius were to keep on going, okay, regardless, it would still bisect that chord. So if the entire chord is 20, then each side here is going to be 10. So I can go ahead and solve for x by, again, just doing the Pythagorean theorem. 10 squared plus x squared is equal to my hypotenuse, which is 19 squared. And now we can go ahead and solve for x. So that's going to give me, I believe if I go ahead and solve that, I'm going to get x is equal to 16, alright, phew, x is equal to 16.16. Alright. Alright, nice job. Okay, so now these are going to start getting a little bit trickier, okay? We're going to have to think about these a little bit more here. Number 4 says, two circles intersect and have a common chord. Okay, so think back to elementary school, and I'm going to do my best to draw this. Think back to elementary school when you have two circles that intersect like that. Okay, we called that a Venn diagram back in elementary school. So it says two circles intersect and they actually share a chord, meaning that they have a common chord that's a part of both circles. So remember, a chord is just a point, 2 points that are connected on the circle. Okay. So I'm going to make my common chord here. Okay. And it tells me that that chord is equal to 26 centimeters long. The centers of the circles, so I basically, again, I have two separate circles here, so let's just say the center of this first circle, circle 1, is about right there. And the center of this circle, circle 2, is about right there. It says the centers of the circles are 25 centimeters apart. Okay, so I'm going to connect the two centers, okay? And I know that those are 25 centimeters apart. It says the radius of one circle is 20 centimeters. Okay, so I'm going to go ahead and I'm going to draw the radius so I can create a triangle here. It says the radius of one of the circles is 20 centimeters. So I'll say the radius of this circle right here is 20. And it wants me to find the radius of the other circle. Okay, so what it wants me to find is this radius right here. Okay, so we'll call that x. So take a second, kind of finish this up, digest what we've been talking about, and then we'll move on with the problem. Alright, so one thing that it says in the beginning, it says that this common chord right here is 26 centimeters long. Okay, well, since we're connecting the centers of the circle, okay, since we're connecting the centers of the circle, that means that each half of this chord right here is going to be 13. Okay, since this entire chord right here is 26, I'm connecting the centers. Okay, so since the center of the circle is being, or since this chord is being bisected, okay, I have a right angle. Okay, let's go ahead and draw that in. What's going on here?